Row 1. Text, Notepad window, text editor, editing. Remember, this is not teaching man teacher. It is useful for recalling, when exam coming man student. Just selected. Close eyes, just. Eyes selected. Based on G scheme for electronics engineering group. Subject selected. Blank. Subject, microcontroller, 17534. These are mostly important questions which is always repeat. Form top to end it reduce repeated changes. X question 1 is more important than 2 in notes. And note warning sign that this is not all chapter.
Microcontroller Chapter 4. 1. E. Draw the format of SCON register of 8051 microcontroller, and explain the function of each bit. ANS, SCON register format 2 marks, explanation of each bit 2 marks. SMO SM1 SM2 REN TB8 RB8 T1 R1. SM0 SCON.7 serial port mode specifier SM1 SCON.6 serial port mode specifier. SM2 SCON.5 used for multiprocessor communication, make it 0. REN SCON.4 set / cleared by software to enable / disable reception. TB8 SCON.3 not widely used. RB8 SCON.2 not widely used. TI SCON.1 transmit interrupt flag. Set by hardware at the beginning of the stop bit in mode 1. Must be cleared by software. RI SCON.0 receive interrupt flag. Set by hardware halfway through the stop bit time in mode 1. Must be cleared by software. Note, make SM2, TB8, and RB8 equals 0. SM0 SM100 serial mode 001 serial mode 1, 8-bit data, 1 stop bit, 1 start bit 10 serial mode 211 serial mode 3. SM2 is the D5 bit of the SCON register. This bit enables the multiprocessing capability of the 8051. Make SM2 equals 0 since we are not using the 8051 in a multiprocessor environment. REN, the REN, receive enable, bit is D4 of the SCON register. The REN bit is also referred to as SCON.4 since SCON is a bit addressable register. When the REN equals 1, it allows the 8051 to receive data on the RxD pin of the 8051. As a result, if we want the 8051 to both transfer and receive data, REN must be set to 1. By making REN equals 0, the receiver is disabled. Making REN equals 1 or REN equals 0 can be achieved by the instructions set SCON.4 and CLR SCON.4, respectively. This bit can be used to block any serial data reception, and is an extremely important bit in the SCON register. TB8, transfer bit 8, is bit D3 of SCON. It is used for serial modes 2 and 3. We make TB8 equals 0 since it is not used in our applications. RB8, receive bit 8, is bit D2 of the SCON register. In serial mode 1, this bit gets copy of the stop bit when an 8-bit data is received. This bit, as is the case for TB8, is rarely used anymore. In all our applications we will make RB8 equals 0. Like TB8, the RB8 bit is also used in serial modes 2 and 3. Microcontroller Chapter 4. 2. TI, transmit interrupt, is bit D1 of the SCON register. This is an extremely important flag bit in the SCON register. When the 8051 finishes the transfer of the 8-bit character, it raises the T1 flag to indicate that it is ready to transfer another byte. The TI bit is raised at the beginning of the stop bit. RI, receive interrupt, is the D0 bit of the SCON register. This is another extremely important flag in the SCON register. When the 8051 receives data serially via duct RxD, it gets rid of the start and stop bits and places the byte in the SBUF register. Then it raises the RI flag bit to indicate that a byte has been received and picked up before it is lost. RI is raised halfway through the stop bit. I, with the help of suitable diagram, describe the serial communication modes of 8051 microcontroller. ANS, 1 mark for each mode. 8051 microcontroller communicate with another peripheral device through RxD and TXD pin of port 3. Controller have 4 mode of serial communication. This 4 mode of serial communication are below. 1. Serial data mode 0 fixed baud rate. 2. Serial data mode 1 variable baud rate. 3. Serial data mode 2 fixed baud rate. 4. Serial data mode 3 variable baud rate. 1. Serial data mode 0, baud rate fixed. In this mode, the serial port works like a shift register, and the data transmission works synchronously with a clock frequency of FOSC/12. Serial data is received and transmitted through RxD. 8 bits are transmitted/received 80 a time. Pin TXD outputs the shift clock pulses of frequency FOSC/12, which is connected to the external circuitry for synchronization. The shift frequency, or baud rate, is always 1/12 of the oscillator frequency. 2. Serial data mode 1, standard UART mode, baud rate is variable. In mode -1, the serial port functions as a standard universal asynchronous receiver transmitter, UART, mode. 10 bits are transmitted through TXD, or received through RxD. The 10 bits consist of 1 start bit, which is usually 0, 8 data bits, LSB is sent first/received first, and a stop bit, which is usually 1. Once received, the stop bit goes into RB8 in the special function register SCON. The baud rate is variable. Microcontroller Chapter 4. 3. Serial data mode 2 multiprocessor, baud rate is fixed. In this mode 11 bits are transmitted through TXD, or received through RxD. The various bits are as follows: a start bit, usually 0, 8 data bits, LSB first, a programmable 9th, TB8, or RB8, bit, and a stop bit, usually 1. While transmitting, the 9th data bit, TB8 in SCON, can be assigned the value 0 or 1. For example, if the information of parity is to be transmitted, the parity bit, P, in PSW could be moved into TB8. On reception of the data, the 9th bit goes into RB8 in SCON, while the stop bit is ignored. The baud rate is programmable to either 1/32 or 1/64 of the oscillator frequency. F baud equals 2 SMOD/64 FOSC. 4. Serial data mode 3 multiprocessor mode, variable baud rate. In this mode 11 bits are transmitted through TXD, or received through RxD. The various bits are: a start bit, usually 0, 8 data bits, LSB first, a programmable 9th bit, and a stop bit, usually 1. Mode 3 is same as mode 2, except the fact that the baud rate in mode 3 is variable, i.e., just as in mode 1. F baud equals 2 SMOD/32, asterisk, FOSC/12, 256th1. A. Draw the format of TCON register of 8051 microcontroller, and state the functions of each bit. ANS, format, 2 marks explanation, 2 marks. TF1, TCON. 7, Timer 1 Overflow Flag. Set by hardware when the timer/counter 1 overflows. Cleared by hardware as processor vectors to the interrupt service routine. TR1, TCON. 6. Timer 1 Run Control Bit. Set/cleared by software to turn timer/counter 1 on/off. TF0, TCON. 5. Timer 0 Overflow Flag. Set by hardware when the timer/counter 0 overflows. Cleared by hardware as processor vectors to the service routine. TR0, TCON. 4. Timer 0 Run Control Bit. Set/cleared by software to turn timer/counter 0 on/off. IE1, TCON. 3. External Interrupt 1 Edge Flag. Set by hardware when external interrupt edge is detected. Cleared by hardware when interrupt is processed. IT1, TCON. 2. Interrupt 1 Type Control Bit. Set/cleared by software to specify falling. Microcontroller Chapter 4. 4. Edge/low-level triggered external interrupt. IE0, TCON. 1. External interrupt 0 edge flag. Set by hardware when external interrupt edge detected. Cleared by hardware when interrupt is processed. IT0, TCON. 0. Interrupt 0 type control bit. Set/cleared by software to specify falling edge/low-level triggered external interrupt. B. Write an ALP for 8051 microcontroller to generate delay of 1 second by using timer 1. Use crystal frequency equals 12 MHz. ANS, 1M calculation, 2M program, 1M comments. Crystal frequency equals 12 MHz. Timer frequency equals 12 MHz/12 equals 1 MHz. Time equals 1/1 MHz equals 1 us for delay of 50 milliseconds. 50 ms/1 us equals 50,000. Therefore count to be loaded in TH1 and TL1 can be calculated as 65536-50,000 equals 15536D equals 3 CB0H program. Move TMOD. Hashtag 10H, timer 1, mode 1 here, move R0, number 20, counter for 1's delay, 50 ms * 20 equals 1 SEC, CPL P2.0, complement P2.0 back, move TL1, hashtag B0H, load count value in TL1 move TH1, hashtag 3CH, load count value in TH1 set TR1, start timer 1 again, JNBTF1, again, stay until timer rolls over. CLRTR1, stop timer CLRTF1, clear timer flag DJNZ, R0, back. If R0 is not equal to 0, reload timer SJMP here, repeat. C. Write an assembly language program for 8051 microcontroller to generate a square wave of 1 kHz on P1.5. Assume crystal frequency as 11.0592 MHz. ANS calculations -1 mark, delay 1 MK, program -2 marks. Crystal frequency equals 12 MHz I/P clock equals 11.059 x 10.6. /12 equals 1 million equals 921.58 kHz T in equals 1.085 mu SEC for 1 kHz square wave. Microcontroller Chapter 4. 5. F out equals 1 kHz, T out equals 1/1x103, T out equals 1000 mu SEC. Consider half of it equals tout equals 500 mu SEC. N equals T out slash tin equals 500 divided by 1.085 is equal to 460.8265536-461 equals 65,075. 10 equals FE33 16 program move TMOD #01H set timer 0 in mode 1, i.e. 16-bit timer L2 move TLO #33H load TL register with LSB of count move THO #FEH load TH register with MSB of count set TRO start timer 0 L1 JNB TFO L1 pole till timer roll over CLR TRO stop timer 0 CPLP 1.5. Complement port 1.5 line to get high or low. CLR TFO. Clear timer flag 0 SJMP L2. Reload timer with count as mode 1 is not auto reload. B. Draw the format of TMOD register of UC8051 and describe function of each bit in it. ANS. Format 2 MKS. Function of each bit 2 MKS. Microcontroller Chapter 4. 6. 3. Draw the format of PSW register of 8051 microcontroller and explain the function of any two flags. ANS flag register format 2 marks, explanation 2 marks, any two flags. 1. CY, the carry flag. This flag is set whenever there is a carry out from the D7 bit. The flag bit is affected after an 8-bit addition or subtraction. It can also be set to 1 or 0 directly by an instruction, such as SETBC and CLRC, where SETBC stands for set bit carry and CLRC for clear carry. 2. AC, the auxiliary carry flag. If there is a carry from D3 and D4 during an ADD or SUB operation, this bit is set, it is cleared. This flag is used by instructions that perform BCD, binary coded decimal, arithmetic. 3. F0, available to the user for general purposes. 4. RS0, RS1, register bank selects bits. These two bits are used to select one of the 4 register banks and internal RAM in the table. By writing zeros and ones to these bits, a group of registers R0, R7 can be used out of 4 registers banks in internal RAM. 5.OV, the overflow flag. This flag is set whenever the result of a signed number operation is too large, causing the high order bit to overflow into the sign bit. In general, the carry flag is used to detect errors in unsigned arithmetic operations. The overflow flag is only used to detect errors in signed arithmetic operations. Microcontroller Chapter 4. 7. 6p. Parity flag. The parity flag reflects the number of ones in the A accumulator register only. If the A register contains an odd number of ones, then P equals 1. P equals 0 if A has an even number of ones.